that when we ended our last class, we had just made the exciting discovery that this particular rational function has not one but two vertical asymptotes, and we have placed the vertical asymptotes, both of which make the denominator equal to 0. Now let's go ahead and continue with the x and y intercepts. So the y-intercept when when x is equal to 0 would be 0 plus 3 over 0 squared plus 0 minus 2. What I want you to notice is anything that has an x in it is going to automatically be 0. So the y-intercept is always the constant of the numerator divided by the constant of the denominator. So you can quickly spot it by just looking at the equation is 0, negative 3 halves. So I'm going to go ahead and plot that point. 0, negative 3 halves, negative 1 1/2, which is about right here. Y-intercept or x-intercept occurs when the numerator equals 0. Remember, the denominator doesn't matter what the denominator is. 0 over 5, 0 over 10, it doesn't matter, it's still 0. So x plus 3 equals 0, and so our x-intercept is negative 3, 0. So we have another key point at negative 3, 0. Now, what happens as x gets very, very big? That determines our asymptotes other than the vertical asymptote. It would determine a horizontal or other non-vertical asymptote. So x goes to plus or minus infinity. So we're thinking, let's put a really, really big number. So this one, rather than actually, well, I'll plug in a number. If I plug in 1,000,000, you'll see that I would have 1,000,003 all divided by 1,000,000 squared. Well, that would be 1,000,000 with 12 zeros after it, plus another 1,000,000 minus 2. So this is a really, really large number. As we increase x even more, that squared term, whatever that squared term is, that's going to dominate. It's going to keep getting bigger at a much faster rate than x is. So what happens as x gets really, really big is that this whole, the y value gets closer and closer to 0. So we're looking at a horizontal asymptote at 0, approximately 0. So horizontal asymptote is the x-axis again. So, oh, look at this. Here's a case where we have a we have an x-intercept and an asymptote on the x-axis. So the graph either just touches or crosses the asymptote here. As I told you that it can, other than the vertical asymptote, it could touch or cross. Now, at this point, we have to think about what is the graph doing in these various sections. So we have this section up here or down here. What's happening in this middle section between the two vertical asymptotes? What's happening over on to the right of the right-hand vertical asymptote? So first of all, we only have one x-intercept. We know that because only one value makes the numerator equal to 0. So that's the only place it can touch or cross the x-axis. So when you notice right in this little middle section, if it can't cross the x-axis and it can't cross either of the vertical asymptotes, the only possible thing that can happen in this middle section is something like this. So there's our middle section of the graph. But we really don't know what's happening to the left of -2 or to the right of +1. And we don't really know what's happening in between the point here, that x-intercept, and the asymptote at -2. So we're going to do what's called a sign test. A sign test is just kind of a shortcut to plugging in points. So you can actually plug in points. I'll show it both ways. But I want to look at think about dividing the graph into different segments based on knowing certain key points for x. So our first key point for x we know is that x equals -3 is y equals 0. What happens to the left or right of that, we're not sure though. So I'm going to start with one section of the graph that I'm interested in finding out is what happens between -infinity and -3. Then I know what happens at -3. So when x equals -3, y equals 0. I know that. So it's kind of that's a known quantity. So I'm really not concerned, so I don't know, I'll put the point -3, 0. We have that, -3, 0. Okay, we know that is my x-intercept. Okay, then my next section of the graph that I want to find out about is what happens. I'm sorry, I don't really like the way I wrote that. I'm just going to write that we know at -3, then we have that we have the y-intercept, or x-intercept, sorry, we know that one. Okay, then we have a point between -3 and -2. And at -2 we have the vertical asymptote. Okay, so we know that. Then we want to know what happens between -2 and 1, and we actually know what that is, but I'm going to put that in there. Then we have at 1, we have another vertical asymptote. And then what happens between 1 and +∞? Once again, I didn't write that very nicely, 1 and +∞. So let's see what happens there. Now, what I'm going to do is take the factored form of the equation. F of x is equal to x, I need to look up here, x plus 3 over x minus 1 times x plus 2. This is easier to do when we're in factored form. Now I'm going to plug a number less than -3 into this equation. So imagine any number less than -3. It doesn't matter what you pick. So let's say we pick -4. My numerator is -4 plus 3, which is a negative number. My denominator, -4 minus 1, is a negative number. And -4 plus 2 is also a negative number. So I have a negative divided by a positive, because negative times negative is a positive. So the whole thing is going to be negative. In other words, y is going to be less than 0. If I know y is less than 0 in this section, then that tells me that my graph has to go below the x-axis but run along next to it because it's an asymptote, but it's below the x-axis in that section of the graph. Now what happens between -3 and -2? So let's imagine putting -2.5. Well, if we put -2.5 in the numerator, I have that gives me a positive number. If I put -2.5 in the factor x minus 1, that gives me a negative number. If I put -2.5 and add that to 2, that's still a negative number. So altogether, I have a positive divided by a negative times a negative. That means a positive number. So that tells me y is greater than 0 in that interval. So I know that it has to go above the x-axis and run along the asymptote like I just drew. Now, I already know that y is negative here, but let me just show you how this works. Pick a number between -2 and 1, like 0. 0 plus 3, a positive number. 0 minus 1, a negative number. 0 plus 2, a positive number. I have a positive divided by a negative times a positive, so that gives me a negative number altogether. Y less than 0, that's what I have. So that's what I see on the graph. All of my y values are less than 0. Last one, 1 to +∞. Let's put in 2 for x. So positive number on the top. 2 plus 3 is 5, positive number. 2 minus 1, positive number. 2 plus 2, positive number. Y is greater than 0 if I have any number greater than 1. So that means since it can't cross the vertical asymptote and I have no more x-intercepts, the rest of the graph must all be above and to the right of the 2 asymptotes. So this is known as a sign test. This is a really handy way to just divide your graph kind of into sections and just analyze what is it doing in these sections. Now, you can always make a t-chart and do the same thing, but recognize where you need to pick points. You need to pick points in between x values you already know, and that's the key, to pick those key points.